Hey everyone, welcome back to my YouTube channel. We're back at solving Leet Code challenges, and in this video we'll be solving Leet Code 9, which is to detect if a given number, if a given integer is a palindrome or not. Let's go ahead and solve it. Let's have a look at what is a palindrome number. A palindrome number is a number that remains the same when its digits are reversed. For example, if I have 1 to 1 here, and when I reverse 1 to 1, I'll get 1 to 1 again, and they both are the same numbers, so we can say it is a palindrome. If we take another example, say 1 2 3, in this case when I'll reverse the number, I'll get 3 2 1, which is not the same as 1 2 3, so it's not a palindrome. Similarly, we can have a longer number, but as long as it stays the same when we reverse it, it will be called a palindrome. For example, 16461. Now when we reverse this, we get 16461. And as they are the same, so we can say 16461 is a palindrome number, whereas 123 is not a palindrome number. Now let's have a look at the algorithm that we'll be using to solve this problem. The algorithm is very simple, that we'll first reverse the number, then we'll check if the reverse is equal to the original number or not. To get the reverse, let's say we have number 16461 and we keep a reverse number initialized as 0. Then we just have to continue on dividing the number by 10 till it becomes 0, and we'll keep adding that to reverse, and this is what we're going to do. Say number is 16461, we divide it by 10, we'll get the quotient as 1646 and remainder will be 1. Then this formula is important, that reverse at every step will be reverse into 10 plus remainder, because we are taking the least significant digit and then adding it to the number, so that's why we have to multiply it by 10 here. In this case it will be 0 into 10 plus 1, so we'll get 1 as the reverse and 1646 is our quotient. In the next step we'll use 1646 divided by 10, we'll get quotient as 164 and remainder as 6. Now reverse will be again reverse into 10 plus the remainder, so we'll get 1 into 10 plus 6 and we'll get 16. Then this quotient will be used again, we'll divide 164 by 10, we'll get quotient as 16, remainder as 4, and now reverse will be 16, which is the previous reverse, into 10 plus 4, and we'll get 164. The quotient is still greater than 0, so we'll continue. We'll do 16 by 10. Quotient will be 1, remainder will be 6, and reverse will come out to be 164 into 10 plus 6. We'll get 1646. Quotient is still greater than 0, so we'll continue and we'll do 1 divided by 10. We'll get quotient as 0 and remainder will be 1. The reverse will come out to be 1646 into 10 plus 1, 16461. Now our quotient is 0, so that will be the termination of the algorithm, and here we have the reverse of the number. We'll just compare if this value is equals to the initial number. If that's the case, then it's a palindrome number, otherwise it's not. Okay, let's go ahead and implement this in code. We'll be able to write it down in just 10 lines of code. Let's do it. Here I have the problem statement in front of me. Given an integer x, return true if x is a palindrome, false if not. We'll go ahead and code the algorithm to reverse the number, and then we'll just compare that reverse number with the original number. That will tell us if that number is a palindrome or not. So I'll just take an integer, say reverse, which I'll initialize with 0, and then while x is greater than 0, we'll go ahead and code our algorithm. I'll also need a remainder, and here we'll set remainder equals to x mod 10, so we get the least significant digit, and we'll set reverse equals to reverse multiplied by 10 plus the remainder, and at the end we'll set x equals to x divided by 10 so that we get the next quotient, and this will keep on running while x is greater than 0. By the end of this loop we'll get the reversed number, and we'll have to compare it with the original number. In this piece of code we'll lose the original number because we are dividing x by 10 and then reusing x. So I'll just save x initially in a variable, say original, and at the end I can compare the computed reverse and the original variable. If they are the same, then it's a palindrome, otherwise it's not. So I can directly return reverse equals to original. Let's try to run it. So it works for the given test cases. Now I'll just go ahead and submit it. So we can see it took 8 milliseconds of runtime and 5.9 MB of memory space, and the solution got accepted. If we talk about the time and space complexity of this algorithm, the time complexity will be O log n, because in each iteration we are dividing x by 10, and our check is we'll have to keep iterating till x is greater than 0. So we are reducing our problem set in each iteration, hence the time complexity is log n. And when we talk about the space complexity, since only these variables are being used and there is no added space inside the loop, so it's a constant space complexity of O1. So time complexity is log n, O log n, and space complexity is O1. I hope I was able to help you with that solution. If you want me to solve any particular problem, please put it down in the comment section below, and subscribe to the channel for more learning content. I'll see you in the next one. Peace out.